Good day, grade 9s. I'm Ms. Todd, and today's lesson will be about acids, bases, and the pH value. For this section, we are going to look at what different acids are, what different bases are, and how to use a pH scale to determine the pH values of different acids and bases. Let's get started on what examples are of acids and bases. Let's start with acids. We have a few acids here to give you an idea on what they are. Hydrochloric acid is our first one. It can also be known as stomach acid. We also find acid in soft drinks or cold drinks. There is citric acid in different citrus fruits, as well as acetic acid in vinegar. The last one there is sulfuric acid, and sulfuric acid can be found in different batteries, mainly car batteries. If we have a look at bases, some examples of what different bases are is Handy Andy, Sunlight, kitchen cleaners, baking soda, and bicarbonate of soda. All of these are examples of bases. Let's have a look at what the differences are between acids and bases. So acids tend to have a sour taste if they are safe enough to taste, and bases tend to have a bitter taste. Acids, if you were to feel them, obviously for us in a safe manner, they would feel rough, and bases would feel smooth or soapy. With regards to acids, which is what we'll do next when we speak about the pH value, acids have a pH value that's less than 7, and bases have a pH value which is more than 7. With acids, they tend to have hydrogen in front of the chemical formula and hydroxide at the end of the chemical formula. And when we mix an acid in water, we call it an acidic solution. And when we call a base mixed in water, it is called an alkali or an alkaline solution. So let's have a look at the concept of pH value. pH value, or the pH, is a measurement of how acidic or how basic a substance is. In order to determine the pH value, we use a pH scale, which is a set of numbers that ranges from 0 to 14 and will indicate how acidic or how basic a substance is. If we have a look at acids, acids will have a pH value that ranges between 1 and 6. Bases or alkalis will have a pH value that ranges between 8 and 14, and neutrals will have a pH value of 7. So in order to determine the pH value, we use the pH scale. As you can see here, acidic substances or acids will have a pH value that ranges from 1 to 6. Alkalines or alkalis or bases will have a pH value that ranges from 8 to 14. And neutral substances will have a pH value of 7, and that can all be taken or determined by using the pH scale. There are some lab acids which you should know. These are the three which we'll be working with for the next few chapters. We have hydrochloric acid, which has a formula of HCl, nitric acid, which has a formula of HNO3, and sulfuric acid, which has a formula of H2SO4. Now, some safety or important safety factors to remember when working with acids. Acids are always diluted with distilled water, and we never use concentrated acids. The reason for this is that they are just too strong. When you are pouring an acid to make it diluted, you never throw the water into the acid. You must always throw the acid into water. Something else to remember when you do work with acids and bases is to make sure that you wear gloves and goggles and masks if necessary. Now we move on to what an indicator is. An indicator is a substance that is used to test whether something is an acid, a base, or a neutral. Now what's important with indicators is that we are mainly looking for a color-specific change which occurs if we add a specific indicator to an acid or base. So some of the lab indicators which we use is universal indicator, universal paper, bromothionyl blue, red litmus paper, methyl orange, blue litmus paper, and phenolphthalein. So if you have a look at this diagram over here, this is an indication using litmus solution. So if we add litmus solution into an acid, it turns red, and if we add it into a base, it turns blue. Some natural indicators which we use is red cabbage juice, black tea, turmeric water, and beetroot. Now, these are just household indicators which you are able to make at home, or you are able to buy the ingredients to make these indicators, and they will also determine whether a substance is an acid or base. Universal indicator, which is this diagram over here, can be used to determine the different pH values of acids and bases according to the color change that occurs. So when we speak about color-specific changes in lab acids, we use these indicators. So universal indicator, if it is placed in an acid, it turns a red, orange, or yellow color depending on the strength of the acid. If it is placed in a neutral, it turns a green color. And if it's placed in a base, it turns a blue, violet, or purple color depending on the strength of the base. Bromothymol blue, if it is placed in an acid, it turns a yellow color. If it's placed in a neutral, it turns a green color. And if it is placed in a base, it turns a blue color. Our third indicator is pronounced phenolphthalein. Phenolphthalein is a colorless, clear solution that if it is placed in an acid, it remains colorless. If it is placed in a neutral, it remains colorless, but if it is placed in a base, the solution turns a red-pink color. Our last one here is litmus paper. We work with two different types of litmus paper. If a substance is an acid, the blue litmus paper turns red, but remains blue in a base. If a substance is a base and we use red litmus paper, it turns blue. But if it is an acid and we use red litmus paper, it remains the same. Now, something important to remember when we speak about indicators. Indicators that are used, like the above ones we've mentioned, do not change the properties of the substances. They simply indicate to us whether a substance is an acid or base. I have an example here showing you the different color changes of substances using universal indicator. The first one poured there shows us that that substance is red and it is an acid. The orange and yellow also indicate that that substance is an acid. The green, if universal indicator is placed in it, shows us that it is a neutral, and the blue and purple indicate to us that it is a base. To give you a better idea on how the pH scale works, if we go to our first arrow over here, the lower down we go on the pH scale, the higher the strength of the acid goes, which means the strength increases of acids. If we look at number 7 over here, any substance that has a pH value of 7 shows us it's a neutral. And if we go from 8 down to 14, that is the increasing strength of bases. So as an example, if we go to number 14 over here, if a substance has a pH value of 14, it means it is a strong base. And if we go to number 1 over here, if a substance has a pH value of 1, it means it is a strong acid. But if we go to number 6 over here, if a substance has a pH value of 6, it means it is a weak acid. And if we go to number 8 over here, if a substance has a pH value of 8, it means it is a weak base. Thank you for coming to my lesson in grade 9s. We'll see you next time for part 1.